Hey guys, this is going to be a tutorial on some flow control and helpful nodes in Unreal Engine 4. So first I want to introduce the delay node. The delay node is very simple. It's a node that it basically delays the execution of code for the duration. So if I had a print string here and I had an event that called it, it would wait 0.2 seconds before firing the print string. Next is the retriggerable delay. This is the same thing as the delay, except every time this pin is ran, it basically resets the timer. So while the delay will always wait for 0.2 seconds and then fire it, this will only fire once the 0.2 mark is reached, and if this is triggered again, it resets the time. So if you have an event constantly firing on this every frame, it is theoretically impossible to fire whatever runs on the completed node, because every frame the timer would be being reset for the delay. Both very helpful, but can only be used in macros or in the event graph and cannot be used in functions because they are latent actions. Perform a latent action with a retriggerable delay. Typically is indicated by this clock. The timeline is another latent action that you can't call in a function that is very helpful. What it does is that it has a length that you can and it has a start and an end, and it essentially has curved data inside that you can set, and you can do that by double clicking on the timeline. It'll open up this menu, and you'll have options of types of variables you can add. Commonly, float tracks are used, and we can call this float. You can then define how long this node will run, such as for 1 second. And you can right click add key, select the time for the first key, such as 0, and then what value it'll be at that point. And you can add another key, and you can set what time and what value. In our case will be 1. And now you'll notice we have a curve. So when time starts at 0, when time is 0, the value will be 0. When time is 1, the value will be 1. There's other values here, like use the last keyframe, whether this timeline should autoplay whenever the blueprint is active, whether the timeline should loop forever, essentially working like an event tick, whether this is replicated, and whether it should ignore the slowdown of time. And what they will do is essentially for 1 second, once the play is fired, or play from start, it'll every tick call this print function. And you'll also have access to do something once the timeline has finished. And notice how the float track we've made is now here, so it is accessible. So you could use this data here to control an alpha, such as a lerp, to make a character go from one point to another in a certain amount of time. That's one way of using it. There's also cool things you can do by reversing it. So you can think of it like a video track, reversing the video, and it will still update throughout. And you can reverse from the end, and you can set a new time, so you can go to a certain time in the timeline. Next, we have the doEnd node. This will essentially do something a certain amount of times you tell it. So this will only allow things to run a certain amount of times. So it won't do something the amount of times you want it to. It'll only allow the thing to happen a certain amount of times. So if I want this print string to only fire 3 times, you could put 2 or 3, depends, and it will only fire this amount of times. So this will only say print string 3 times, I think, or it might be 2. 0 and 1, 2, 3 programmer stuff. So along the same vein is the doOnce node. The doOnce node only fires the event once. So while this allows you to do it the whatever's to the right of this to fire n amount of times, and the do once node will only allow it to fire once. So this is like do n, but with a 1. What will happen for both of these, especially this one, is that once they fire, they get closed and they won't be able to fire anything to the right. However, if you have an event that goes and fires this reset, it essentially resets the counter, and the do n will once again be able to allow things 3 times through, and the do once node will allow whatever's to the right of it to fire it one more time once it's reset. So again, once these two fire, they're closed, and once these fire, they're closed depending on their conditions. So this one, after 3 times, it will close. This one, after 1 time, it will close. And you can reset that with the reset pin. Next, we have the flow, the flip-flop. Flip-flop essentially goes between A and B every time it's fired. So the first time it gets fired, it'll fire A. Second time it gets fired, it'll fire B. Third time it gets fired, it'll fire A. Fourth time it gets fired, it fires B. It's sort of like a light switch, and it's typically used for light switches in games. Next is the gate. The gate you can think of as a door. Your goal is to control whether this gets fired or not. If the door is open, this will fire. If the door is closed, it'll stop here and it won't fire anything to the right. You can control whether the door is open or not by having events or executions feed into the open or close events of the gate. Or you can do a toggle to swap between off and on its current state. And the enter node is essentially where it'll typically go through, right? It will go into here. Am I allowed to enter? If I am, it will fire to the right. If I'm not, it will stop right there. You'll notice by default it says start closed. If you want your thing to fire once and then close, you could turn this to false, and now it won't be closed. And you could do something like this, right? Where it will go through, it'll fire, and then it'll close the gate so it can't be fired again. Next is a for loop, pretty common programming tool. It will it will execute whatever is in the loop body the certain amount of times relative to the index. So if this is 0 and this is 3, this would fire either 2 or 3 times, whatever is in the body loop. So this will fire it repeatedly, not to be confused with do n. Do n is supposed to allow things once every time it's fired. So if this doesn't do it 3 times, what it does is that it will allow this to be fired 3 times, where this will fire once and do it 3 times immediately. So it'll call print string 3 times almost instantly, and then you also have the chance to use the completed node. Once the loop is completed, it will allow you to also run something else. A for loop with break is sort of the same thing as a for loop, except if you are going through your body code, and let's say you're checking to see if a float you can get to see if a float is greater than 1. If it's true, right? So you're going through this for loop, and once this becomes true, you could do something like break, and this will essentially break the for loop. So it won't go from 0 to 3. It'll go from example for 0 to 2, and then it would break it, so it would never fire the 3rd time. Next, we have a multi-gate. A multi-gate basically executes a series of pin in order. This is sort of similar to the sequence node, where once it goes in, it'll fire 0, and then it'll fire 1, right? And you can add any number of pins, and this is really good so you can organize your code better. Now, where the multi-gate differs is that it is a sequence, but you can control, it can fire these events randomly if you turn on isRandom, and you can make it loop repeatedly, right? Additionally, you can reset this. If this is set to -1, it would loop forever. You can also have it run a certain amount of times by controlling the start index. And you can reset it if you want it to loop again. The isRandom is especially helpful, for example, if you wanted to give a character a buff that was random. You could have a series of add buff functions, and it would pick a random one. It would pick a random one, but it would eventually go through all of them. So it would give them the buff in a random order. Next is just the branch node, which you're pretty familiar with. These are probably just if statements in code. This checks to see if a condition is true or false. If it's true, it'll fire this. If it's false, it'll fire that. Simple. But a little less simple, but still pretty helpful, are switches and the select node. So both of these events are firing functions, and the result will be the same for both of these. The first one uses a switch node, which essentially gets this enumerator I have, which has values of player, enemy, and NPC. If I drag off the enumerator and type in switch, it would give me the switch on character types, which we are using here. If this value is a player, it's going to run the execution of anything that is plugged into player. If it's enemy, it'll run this. If it's NPC, it'll run that. So it'll say player if it's player, enemy if it's enemy, NPC if it's NPC. And then they'll all go to enemy. Or just this final string. Now, another way of doing this in a much more compact way would be, instead of calling several functions, you can do a select, which has a return value. And this return value differs depending on the value of the enumerator. So rather than have 3 execution pins and having 3 functions, we have only we only have 1 execution pin and 1 function, and we have a pure function that is returning these values. In our case, it's select. So depending on this value, it'll either say player, enemy, or NPC. And this data gets fed into here, right? And depending on this, it changes what the return value will be, which fires this. So both of these fire the same thing. Both of these are dependent on the value of the enumerator. But this one is a little more compact sometimes. It saves you on having to do more functions. That's it for this tutorial. That was a bit of flow control and helpful latent actions. There'll be more in the future. So stay tuned.